Okay, so good evening, guys. So let us continue our session 3 today. So yeah, yes, somebody were asking something. Session 3, and today and the time is 5:07 p.m. evening IST. Yes, if somebody has any doubt, if anybody is having any doubt, please ask. No? Okay, fine. So now, so we will continue our discussion uh, on one of the very important topic, and that is file system actually. Now, what is a file system? So basically, as I said earlier, that file system is very important because with the help of a file system, you can do any kind of an operation onto a file, right? So because of the file system, you can create a file, you can create a directory, you can delete a file, you can give permission to the file, you can do any kind of an operation onto a file by using a file system. So file system, it is a software actually. It is a part of the operating system, right? So there are so many file systems are there where Linux supports actually. More than 64.
Your voice is breaking, Rajesh.
Sir, now is it for everyone?
We are able to
No,
hear you.
it's
No,
yeah,
Rajesh, we are good. We are good.
Yeah, we are good.
good.
Guys, please let me know if it is breaking up. So what I was trying to tell that the file system is a very important. I mean, it is a software actually, which is a part of your operating system. That will take care of any operations onto the file. Like, for example, you want to create the file, right? You want to create a directory. You want to give the permissions to the files or directories, permission to the files or directories. So, or else you are doing some operation, you are writing some text, writing some text inside the file, right? You are deleting a file, you are doing n number of operations, or else you are, writing the file, reading the file. I mean, you as a user, we do so many operations actually onto the file. So everything is taken care by your file system software, right? And in Linux, there are various file systems are there, like ext3, extended file system 3, extended file system 4, ext4, ext5, like this. These are the native file system for Linux actually. RIS, Razor file system. Similarly, for the Windows, I already discussed this. We have a FAT, VFAT, NTFS. NTFS is now the default file system for your Windows family, right? So like that, you have a various different types of file systems are there. Now, there are around 64 types of file systems. And Linux almost supports all file systems. Linux supports its own native file system, that is nothing but the ext4 or ext file system, as well as the Linux also supports the NTFS file system also. So, sir, what do you mean by that? What it supports means, what do you mean by that, sir? Can anyone tell me what do you mean by that? Support means?
Support means we can read, write, and just
Correct.
do permission for
Correct.
that file.
Correct. Suppose, for example, you are in a Linux machine. You have a desktop server where you have installed Ubuntu. Suppose you take a pen drive. In a pen drive, you have some file which is having an NTFS file system format or NTFS file system in your pen drive. You try to connect your pen drive into your machine, into a USB slot. As soon as you connect it, what happened? Linux can detect what is a file system type which is there. So it means that when you connect your pen drive, the pen drive has the NTFS file system. The Linux can detect that file system and it will try to mount that device, mount your pen drive. Suppose, assume that in your desktop or in your laptop, you are having a Windows machine and you have a pen drive, and that pen drive is formatted with the ext4 or ext file system, and you have kept the data. Take that pen drive, insert it to the Linux operating system, sorry, Windows operating system. Windows cannot detect at all. It cannot mount that file system, or it cannot mount the device. Then what happens, right? It throws an error saying that unknown file system format. What Windows will give? Windows will throw an error known as an unknown file system format. Because why Windows will throw this error? Because Windows doesn't understand the ext4 or ext5 file system. It doesn't understand that file system at all. How Linux can support so many number of different types of file system? What is the uniqueness what Linux kernel has? Because Linux kernel or the Linux operating system has one special feature known as a VFS, virtual file system. Very good. This is one of the concepts. Because of this virtual file system, Linux can support a number of different types of file system. This is the reason VFS is the only sole reason where Linux can support more than, or whatever the file system we have, right? 64 types of file system. All the file systems are supported by Linux operating system because there is something or the virtual file system layer which is there in the operating system or which is there in the kernel. That is the reason. Okay, fine. Now, so Rajesh, what and all we need to learn in a file system? There is nothing much as a DevOps we have to learn. We have to only learn that what is the structure or how your file system looks like. Suppose you have a file system, how it looks like, or we have to say that what is the hierarchical organization of your file system or hierarchical structure of your file system. In Linux or in Unix, right, the file system is always in an inverted tree structure manner. Always the file system is in an inverted tree structure manner. Always. So this is nothing but your file system. File system. And always it is in an inverted tree structure manner like this. Inverted tree structure manner where always the file system will always start with a slash. The file system will always start with a slash, right? Slash is a ultimate root file system. This slash is a ultimate root file system. Slash is a ultimate root file system. What happened, sir? What happened?
It is white.
Huh?
White. You have select white pen.
Oh, sorry. Sure. Thank you, sir. Thank you. Thanks a lot. Yeah. It is a root file system. Slash is an ultimate root file system. That means that your file system always starts with a slash. Below the slash, there are many other subfolders or directories are there. Like, for example, like this. Some of you know all these things already, but I'm just telling you. But I mean, you have to learn the file system through this way only. Like this. Sorry, the diagram is not that good. I'm not that good in MS Paint, but just try to understand. Okay, slash is an ultimate parent directory. We can even call it as a parent directory also. Parent directory, or you can even call it as the root file system or the ultimate file system, we say. Means your file system begin with the slash itself. It means that whenever you want to enter into the Linux, Rajesh, I want to enter into the Linux, where I can enter into the Linux or how I can enter into the Linux, you can enter into the Linux via with the help of a slash. Slash is an ultimate parent directory, or it is a root file system, we say actually. Below the root file system, below the slash, we call this as a slash partition also. We call it as a slash partition. We even call it as a slash partition. Slash partition. So you can use any kind of a terminology, parent directory, root file system, slash, all are one and the same. Okay. Below this, you have sorry, many other folders actually, or many other directories. Like what are those directories you have? Very important. Bin, sbin. Okay. Sorry, you have home. You have a lib. Tape. You have a root. You have a USR. You have a var. You have a proc. Today morning you are seeing these things. Proc. You have a sys. You have an MNT. You have an OPT. Right? You have a lib. You have yeah, like many things are there. Okay. So this is nothing but these are all the directories which are below your slash. And this whole thing is nothing but your file system. So your file system is in an inverted tree structure. You know, like for example, you say that, sir, how the tree looks like. In general, how the tree looks like, you will say that, sir, always the tree looks like something like at the below you have a trunk, you have a root, sir. Root of the tree is there like this, right? This is a root of the tree, like this. And after that, what happened? This will be below your ground, right? Inside the ground or inside the earth, you will have a root. And afterwards, what happened? What happened, guys? You will get a trunk, a strong trunk will come like this. This trunk will have so many branches like this. The branches might have some more sub branches. This will be a branch. Branch interval might have sub branch, and this some branch will might end with a leaf or a fruit. This is your tree structure, right? If you do it ulta, if you turn around, if you make it 180 degree, what will happen? The root will come at the top like this, right? And ultimately, the trunk is going to come down like this, and the trunk will have so many subdirectories, and so many trunks have sub trunks, and the trunk might end with the branch might end with the leaf or a fruit, right? So this is an inverted. So your Linux follows an inverted tree structure manner where root is at the top. Below you will find a lot of branches, and each branch is ending with a leaf or a fruit, or here we call it as a directory. Did you understand? That's how you can call it as an analogy. We call it as an inverted tree structure where the root is at the top and the below you'll find many directories. Now, this is a very important because the whole functioning of your operating system, it relies on this file system. It means that whenever user is doing any work, he's doing any activity, whenever any process is getting executed, the process will always have information about under which path I am running or under which file system I'm running. Very important point, guys, which I'm saying now. So it means that whenever a user logs in, or whenever any application is running, or whenever any process is running, the process will always be attached to a file system, or the user will be attached to a file system, or an application will hold the information under which file system or under which partition I'm running. So whatever I said now, did you ever heard about this in earlier? Guys,
Yes,
whatever
sir.
I said now,
Yes,
have
sir.
you heard about these things, whatever I said?
Yes, sir.
Huh? What do you mean by
Yes,
that?
yes.
Whatever I said now? I said something, okay. A process is running, it is always under some file system. A user who has logged in, he will be under some file system, or an application is running. So all this terminology, what I'm saying, user, process, or application, everything is in a user space only. So if you try to understand in a high level, you have this user space and your kernel space. We have been seeing again the same thing, the same old story I'm saying. So you are having a user space. and this is the kernel space. You are having a kernel here. Now, what I said here, under the user space, user will log in. A user will log in. Like in our case, CentOS or Ubuntu user has logged in, or Kiran has logged in, or Mahesh has logged in. Any kind of a user who has logged in. These are users actually who has logged in into the user space. So this user are attached to a file system. They are actually working under the file system. This user, he might call a command, like he might call an ls command. He can run an application like a.out application, /a.out application. He can run any application, or he can run any kind of a big application, any kind of a application he runs actually. All these things, whatever a user is doing, actually, it in turn is attached with information, or it runs, or it has information about under which file system I am running or I'm being executed. Very important. People don't know about this. They don't realize, or they don't really want, not really don't want, they don't understand this thing, but this is a fact actually. So that's it. So it understands. So for example, I'm saying here, suppose here you logged in, you are under CentOS. So you are under, if you execute pwd, it will show /home/CentOS. Whenever you execute ls command and enter, right, ls command is getting executed. The ls command is showing you all the files and directories which are there in the present working directory. The present working directory is /home/CentOS. So when the ls command is getting loaded by your shell and it is running, right, so the what happened, right, the shell also gives the information to the process that, oh, you are under this /home/CentOS, you are under this path. So this, when a ls command is getting executed, it understands that, oh, I am under this path, or I am under some file system. And what is the ls meaning? Oh, ls will always try to display all the files and directories which are there in the present directory. Oh, that is what it is getting displayed. Okay, man. It means that it holds it. Fine. So now coming back to here, this is your file system. So file system plays a very major role, directly or indirectly. You might not aware of it, how it works internally. But what happened? Everything is working on a file system only. Now, in this file system, it always starts with a slash. Now, some people might have a doubt. Sir, what do you mean by slash? Is it a partition, or is it a starting of the file system? Yes, it is a starting of the file system. It is also a partition also. Okay. So somebody will ask you, sir, can we equate this slash partition something to a C drive, what you have in Windows? Yes, sir, definitely. You can equate this to a C drive. C drive is nothing but your mother of your Windows. Actually, it means that whenever you are installing Windows, it expects, or it requires minimum one partition where it can install it, and where it can keep all kind of a system configuration file, all your Windows file, everything, and that it called it as a C drive. So I'm asking you one question, very basic question. Can you change the name of the C drive to something D drive, E drive, drive? Does the Windows can detect apart from the C drive name, can it detect the D drive, E drive, F drive, G drive, any other drive, or can it detect as a drive name Rajesh or Mahesh? No, it cannot detect at all. It can only detect as a C drive. Yeah, sure, correct, Ram. Similarly, whenever in Linux you are working a system, it can understand the root of the Linux system, file system, with the help of a slash itself. Without slash, with any other name, it cannot detect at all. But now the interesting things comes that, sir, I have a slash root, correct. But can I rename the slash root? Yes, sir, you can rename it. You can rename it. It is possible. Okay, there is a possibility. So, for example, I'm taking example of Ram. Ram, what happened, right? He can change the partition name itself. He can keep the name as a slash Ram, like this. Slash Lawrence. Change this name like this. So it means that he will be having a partition with the name slash Lawrence, and that itself is a root file system. It is equivalent to the C drive. Slash RAM is a root file system. It is equal to the C drive. So, sir, then how it happened? That is the beauty of Linux, actually. Sir, how you can change this? There is a command which is E2 label. E2 label. I think E2 label, if I'm not wrong, E2 label is there. This is the command, sir. Have you ever come across with this command, guys? No.
No, sir.
100% no, I know that. E2 label is a command through which you can even change the partition name also. But during installation, you can do that actually, not after that. Because once you have given a name, once the slash is taken, right, you cannot do any changes later actually. So, but during installation or during configuration at the very initial stage, you can even change the partition name also. It supports it. Linux kernel can understand. It means that you are only tweaking it. Don't consider the name as a slash Lawrence only, but equate it as a slash only. Equate it to as a slash. Okay, equate it to as a slash. Okay. Yeah. Mohammad Akhtar, Mohammad bhai, koi doubt?
नहीं sir.
Good. Okay. So now, so that is the beauty of Linux. Actually, you can change any partition with any name. The Linux can easily understand. Okay, this is the partition of this. But in Windows, it is not like that. Without C drive, you cannot work on it. Yeah, of course, some other drives which you create, like D drive, E drive, you can give any other name, any other name. Have you seen that so many people, instead of D drive, they're given some other name, Rajesh, Mahesh. Yes, it supports, because that is all, that are all the normal drives. You can give any name. You can change it from the D label to the any other label you can say. So we use this word label actually there. So C drive is there, C drive, but C is actually, we call it as a C label. Similarly, slash partition that, but slash is a label. It is just a name given for a root file system or for the root partition. C drive, it's a name which is given for that root file system of the Windows actually. So guys, did you understand whatever I said? It's just a name or a label is given. But Windows is very strict. They want to keep the name as a C drive only. They don't want to change it, because your operating system, it can function or it can do anything when it sees that C drive. Without C drive, without the name label name C, it cannot do any operations. Clear? Whereas a Linux, it is not like that. You can change the label actually. Okay, fine. Now, after that, what happened, right? Below the slash, you are having so many number of different directories, like bin is there, sbin is there, home is there, lib is there. Right. Go back to your server here. I'll go to the CentOS here. So now what happened, guys? You have a CD command. CD command is basically used for doing a change into a directory. CD means change a directory. CD means change a directory. CD to slash and enter and ls. Can you see here these things? Morning also we saw this. Can you see here? There is a temp also. There's a USR. There's a var. There's a root. There's a proc. OPT, MNT, media, lib, library, home, ECT, so etc, etc. I'm sorry, I missed it. This is one of the important. Some of you know already. etc is so important directory. How I can miss this? etc is a very important directory. Yeah, etc. So you have. So now the question comes, Rajesh, to what level I have to understand these things? Sir, only a basic level is fine for a DevOps engineer. We need not to learn anything. Suppose you are a system admin in your company, you're a system administrator. Yes, system administrator will know in detail about each and every directory. He will know, he has to know, because he'll be playing around with this file system, or he'll be playing around with the Linux system with the help of these directories. As a DevOps engineer, I need not to know a very basic thing I need to know. That's all. No, not many things. So shall we see what are these directories, and just one line information about each and every directory? Can you see that? Yes, we'll go to that now. We'll go through this now. Now, for example, bin is a directory. Bin is one of the very special important directory, guys, where the bin directory, I will write here only, the bin directory will contain all the executable commands. Take, for example, execute ls command, date command, who command, so many commands are executed, right? All those commands, more or less, it will be placed under the bin directory. So what we say, under the bin directory, now you shouldn't say it as just like a bin. You have to say it as a slash bin directory. Under the slash bin directory, all the commands which a normal user and the root user can execute. It means that all the commands, which are all the commands which can be only executed by a normal, which can be executed by all the users, right? He can be a normal user, like he can be a CentOS user, Ubuntu user, Rajesh user, Mahesh user, or any user, whoever execute the command, those commands can be executed by a normal user. Those will be there in the bin directory. Similarly, what happened, right? Those commands which can be executed by the root user, even the root user can also execute all the commands. So bin is a binary directory. We say that it is not but it's a slash bin. All the commands are placed. Suppose here, if I go here, come back here, and if you could see that there is a bin directory is there. Okay, now you could see it, guys. Now, for example, if you see in this is in a sign-in color, it is in a blue color. So it looks like it is a soft link. Now, when I do a slash lsfnl of bin, can you see it's a soft link USR bin? Oh man, got it. Now it's a soft link. So now what I will do here, I want to get into the bin directory. Bin is a soft link, so I will have to do a CD to the bin directory, enter, and say ls. Can you see all the commands which are there? See, all the commands are there. Most of the commands are there in the executable. These are all the commands, guys. If I execute a file command onto this, if I take a file command and if I'm taking this command, this is an executable file. You take any command, all these commands are there. So can you search where is the ls command? See, ls command. You'll find here, somewhere here, you'll see. So most of the commands are there in the bin directory. Clear, guys? But you would see that some file is having a red in color. Some file you have a red in color. Can you tell me what is it? Does anybody has any idea? Those commands which are executed by the super user, which can be executed by the root user, those commands in a red color. Otherwise, all these commands can be executed by both normal user and the root user, but some commands can be executed by the root user. Actually, those commands, some privileges are given. Even the normal user can execute, like ping command. Ping command, even normal user like CentOS can execute it, like ping is 127.0.0.1. Ping can execute it. Ping command, localhost can execute. Even though you are a normal user, CentOS, still you can execute it, because that ping command, it is in the red color. Okay, good, very good. Now what Vaibhav will do, let me do one thing, Rajesh, ls-l ping, let me check. Okay, is there anything is there? Any special permission is given? No, but you could see that it is having a user ID and group ID as root. Oh, beautiful. What about ls, Rajesh? Is having a root. Okay. What about date command? Most of the commands are having a user ID and group ID as root itself. You can execute it, those commands. And you could see that you are having a command which is having a sign-in color. These are all nothing but these are all the soft links actually, right? So it will be pointing to some other command. So ls-l, whatever that SCSI is there, right? SCSI rescan. See, it is actually pointed to the rescan SCSI -bus.sh. So this is a script actually. This script is also there here only. So if I do an ls of this, it is there here only. You can do a cat command onto this. This is a script actually. See, this is a shell script actually. Oh, it means that some command is actually pointing to a script only. Yes, it could be. It is. Yes, this is how. So these are all the scripts, guys. This is one of the script actually. So Rajesh, is it something like the command can be a script also sometime? Yes, it could be a script also sometime. But what happened, right? You cannot have a basic shell script actually to achieve everything. Suppose you are building a complex command actually, where you are trying to do many operations actually. In that case, what happened, right? You cannot implement with a shell script actually. You have to go with a Python or Perl script. So when I was in HP, as I said, right, we were also involved in writing commands, but that command I was writing in the Perl language actually. Using the Perl programming, I was writing a command like this. However, how this command, see how this command, right? It acts like a command. What is that command, sir? HC scan, rescan. This is a command only actually. HC rescan actually. This is a command. This is a command only. I can execute this command, HC, HI, but I mean, it doesn't work here. This is something for SCSI scanning, something. You execute. So you need to run as a root user. Okay. Okay. So now what happened? This is pointing to the shell script actually. So this is a soft link file and it is pointing to shell script. like this. So many times what happens, you will see such thing that where you have a command, but the command might be pointing to, might be soft-link to a script, or it might be soft-link to some other file. So like that, you would see in a real time when you're working in a system. Now, so what is an ultimate thing is that in your bin directory, almost all the commands, whatever executed by the root user or the normal user, will be placed in a bin directory. But bin directory itself altogether is a soft link to the USR bin. Right? Okay, fine, good. Now come out from the bin directory. Now again, you are in the slash. So what is a boot directory? Yes, boot directory. Boot directory. I think I have missed that also. Boot directory. Very important directory, guys, actually. Very important directory. So what is a boot directory contains? Boot directory contains two important special files, sir. One is a VM Linux image and another is a init.rd. These two important files you will find under the boot directory. If you go here and I will do a clear screen by executing command clear. I can run a clear command to clear the screen, or else I can even execute the shortcut known as a Control L. If you do a Control L, like this control and say L, it will also do a clear the screen. This is a shortcut. Okay. So here, do an ls. Can you see there's a boot directory? Yes. Get inside a boot directory and do an ls. Can you see there's a file by name init-ramfs or init? They have renamed it to init-ramfs, but it is init-rd, init-ramfs and VM Linux. And you have something as a grub actually. These are some of the important configuration files or the file which is there in a boot directory. To be very specific, to be very, very concise, actually, this VM Linux image is actually your kernel image. So coming here, this VM Linux image, VM LINUZ, is actually, this is your kernel image. And the init RAM FS is nothing but your root file system image. Oh man, what is this, Rajesh, then? What is this, Rajesh? Then this is a kernel image, VM Linux, this is init.rd image. Yes. So these are two important files. Now you will say, Rajesh, whatever you are speaking about this root file system, whatever you're saying up till now, this slash, blah, 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 parent directory, slash partition, something you told, all these things. Does this is same thing what it is? This is one init ramfs. Is this is same thing what you're saying? Yes, sir. This whole file system, it is in a compressed in a init.rd, init-ramfs. Okay. What is this Linux image? This Linux image is not this VM Linux image. This VM Linux image is nothing but your kernel image. It's a compressed kernel image. So these two important files are there in the boot directory under the boot actually. And you would see that even your grub is also there under the boot directory. Can you connect the dot now? Oh, it means that, Rajesh, okay, what you are trying to say that. So during boot up time, you have this RAM. RAM is divided to two space. User space and kernel space. I'll say US and I'll say case, kernel space. Right? During boot time. And you know that when you switch on a system, you have a BIOS. BIOS will be called actually. BIOS is not but basic input output system. BIOS chip, which has a BIOS code. Now, as soon as you trigger, as soon as you power the BIOS, BIOS will do initial bootstrapping, we say. After BIOS does it, actually, what the BIOS will do, BIOS will give control to the bootloader. That is a grub bootloader. But where is this grub bootloader is there? Oh, this grub bootloader is there under /boot partition. So it is going to call this grub bootloader. What the grub bootloader will do, it will try to detect, it will try to see where exactly the compressed image of our operating system is there. So the grub will understand, oh, under the boot itself, under the boot directory itself, it found that there is two files are there. One is nothing but your VM Linux image and other is a init ramfs. It found these two important configuration file. What it will do, no? What the grub will do, grub will take this file, VM Linux image, it will copy into the kernel space. And the same grub, it will take the init-ramfs and it will take and copy into the user space. And this VM Linux image now, it has been copied into the memory, into the kernel space of the RAM memory. VM Linux image. And here what happened in the root, in your user space, the init ramfs is copied. This file is literally copied. Ramfs is copied into the user space. And afterwards, what happened during the boot process, this VM Linux image, which is in a compressed form, it will be uncompressed. It will get uncompressed. Uncompressed. During the uncompression, what happened, right? The kernel will going to initialize a lot of services. The kernel itself will get initialized. Kernel initializes a lot of drivers. Kernel initializes its own kernel table. There is a kernel table, we say. There's a table, kernel table. Kernel will initialize a lot of other subsystems. Kernel will initialize the memory management, the process management, file management. Finally, you will get the complete kernel, which is up and running. Full-fledged kernel will be up and running. This is what the kernel we are saying now. KRNL kernel. Now this RAM is init ramfs. What happened? It is in a compressed image. It get uncompressed, or else it is extracted. This init ramfs is extracted, and it is extracted. How it is extracted? Internally, it uses something known as a CPIO command. It uses CPIO to extract it. You see here? Have you heard about all these things, sir? CPIO command? No. CPIO. Can you see it? The CPIO command is there. If you go to the manual page, man CPIO. See, copy files to and from archive. It does a CPIO, copy onto the mode actually, copy out mode actually. It is not, but it's an image actually. The image will be converted, will be changed to, it will be extracted and it will be unarchived using the CPIO internally. And then what happened that this init ramfs is nothing but your actual file system. So this is a root file system. So now what happened, right? A slash will be created like this, and it will be, and here what happened, like this will happen. Whatever the root file system you have now, like this. So you have a bin directory, you have a root directory, you have an sbin directory, you have a root directory, you have an etc directory, okay. You have, so whatever I am saying here, whatever you are seeing, all these things, this will be there in a user space. Did you understood? Now you have said that, Sir Rajesh, you never told about these things earlier. You said some user will log in, like Ubuntu, or some process will run, that will interact with the shell, that will interact with the kernel. You said something. Now you're showing completely, you're showing something, a different explanation itself. You are saying this is the actual thing actually. Whatever I'm saying, this is the hard truth. This is what you have to learn, that in a user space, your ultimate root file system will be up and running. Now what happened, right? Now Rajesh, you will say that, Rajesh, you said something on CentOS. Yeah, it is there. Have you seen that there is something, the home directory is also there? Can you see here? There is something as a home directory. Go to the cd / enter and ls. Can you see there's a home directory is there? Yes, there is a home directory is also fine. Home directory is there, fine. Under home directory, which are all the users are there? In our case, under the home directory, if you go to the cd home, you have a CentOS OS. He is the user now who has logged in now. Oh, so it means that Rajesh, whenever user logs in, he will go to the /home and there he has his home directory. Yes. Suppose I created a Rajesh user account, right? For example, I'll go here. I'll say user add command and say Rajesh. Okay, permission denied. Sudo user add Rajesh. Sudo PASSWD Rajesh. Password 123. Password 123. See, Rajesh has logged in. Now, where the Rajesh will be sitting, go to the cd / enter and the ls, go to the home, enter. Can you see Rajesh is sitting? Yes. Now, in a system, when a Rajesh will log in, where he will go and sit, sir? Under / under home, under / Rajesh, here he'll be sitting and he'll be working. It means that Rajesh is a part of the root file system only. CentOS is a part of the root file system. If you create an account by name Kiran will be a part of the root file system. Kishore will be a part of the root file system. Oh man, I think it means that I'm part of the file system and working. Yes, you are a part of the file system and you're working. Now, sir, guys, now you are sitting here in the Windows, actually. You're working in the Windows. This is your desktop, actually. This is your desktop. But this desktop, where you're working, I logged into desktop and with the user, but where you're actually working, you're working as a part of the user only, and you're sitting in a C drive and working. Oh, okay. But how it happens, everything through the file system only, man. You are logging in a system and you're sitting in some place and location in some memory space. You're sitting and working, and that itself is a root file system. Beautiful. This is how you have to understand. Any doubts, guys, you have? So it means that Rajesh, when Rajesh is sitting here and he's doing any kind of an operation, he is interacting with the system through the file system only. Yes, he's interacting with through the file system only. He's interacting with the kernel. So when slash home and when his Rajesh has logged in, Rajesh will get a shell actually, and through the shell he's executing any command, and that shell will communicate with the kernel. Is it clear, guys? Still here?
Yes, sir.
So
Yes.
suppose user with the name Rajesh has downloaded an application and is using the application. If another user logged in, he might get access to that application, sir.
No, because see, now for example, Rajesh has logged in, sir. Now Rajesh has logged in. Now here you could see that I am switching to Rajesh.
Sir.
Rajesh has logged in here. Rajesh will create his own file. I'll create Yash, touch Yash, Pihu. He has created his all files and directories, everything under the home directory Rajesh. Now when exit out, do you think that the CentOS can go cd/home Rajesh? Permission denied. He cannot do, because every user account will have a privilege. It has a permissions. A normal user, he cannot enter into other home directory normal user. But whereas a root user, you switch to the root user. Yes. And a root user go to the home directory of CentOS. Yes, he can see whatever he want. Can he go to the home directory for Rajesh? Yes, he is a super user, sir. He can do anything. Like a system admin in a Windows machine, you have created 10 accounts. Whatever the 10 accounts a user account created, you might have kept your own private files. Does an administrator has an access? Yes, he can go to any home directory. They can check what Rajesh has kept the file, what Mahesh has kept the file, because he's a super user. But a normal user, from one normal to the other normal user, you cannot check what is the content, what is there under his home directory. You cannot check it because you don't have a permission.
Thank you, sir.
Okay.
Sir, how this user isolation happen in this Linux?
No, user, see what happened, no, sir. I will tell you. It's a very good question. What is saying that now, whenever in a system, this is irrespective. It's not only on Linux. Actually, it is common to any operating system. Whenever you log in as a user, okay, the system has to do some kind of a checking. Actually, it has to check whether there is a user with that name, and whatever the user password is giving, right, that password is there or not, or whether the password is matched or not, or whether the password is correct or not. Right? When you give some username and when you give the password, what it does, right? In the back end, there are some security related modules are there which are running in operating system. It checks that whether that username is there or not. Yes, Rajesh, the username is there. Now password is 123. It matches the username and the password, and it allows you to log in into the system. It allows a login to the system. Okay, as soon as you log into the system, right, what happened? The operating system or the kernel, it provides for each and every user, it provides something known as a user ID. User ID is submit, it is a user identification number. Like for example, I want to check the user ID of CentOS. I want to check the user ID of CentOS. If I execute the ID command and enter, see, the user ID is 1000. So this is a specific ID given for the CentOS user. What about Rajesh? Let me do ID. The user ID is 1001. There are many things are there. User ID, group ID, all these are there. Sir, now I want to ask you, where did you saw this word something user ID, group ID? While executing some commands today morning, right? You saw somewhere this. What is that command we execute today morning?
etc password. Cat etc.
Yeah, no. Not it.
Stat command which we run.
Stat command. Stat pu. See? User ID. Group ID. Can you match with this, sir? The ID of the user Rajesh is 101. Sorry, 1001. Can you see there's a 1001 user ID, group ID 1001 ID /Rajesh. Oh man, it means that whenever you're creating a file, that file also has an information about what is the user ID, what is the group ID. Okay, fine. Good. Okay. It's good that. Yes, sir.
Can we make it as a Rajesh user as a sudo user?
Yes, we can make it, sir. It is possible. We have to make it as a sudos. You have to make it under sudo's list. How to do it, we can see later. Don't worry.
Okay. Thank you.
Yes, stat command, correct. Okay. Now, so now coming back to here, now as soon as user ID is provided, each and every user will have some user ID. Already it is provided by your system or the kernel only. So there are, how many users can be created? Okay. There are 65,535 users can be created into the Linux machine. Always the user ID 0 is always for the root user. It is always for the root user. Okay. And what happened, right? From the user ID 0 to up to 999, this number of user IDs are used by the system itself. It means that you cannot allocate the user ID between 0 to 999. No, you cannot do it. 999, you cannot do it because that is already occupied or allocated to the root user. Right? Because the system itself uses that user IDs actually. After that, you have a user ID 1000, you have a 1001, 1002, like that, up to 65,535 users. These numbers are free actually. And all this from 1000 to 1001, these user IDs are given for your normal users. Normal users actually. Rajesh, this concept is there even in Windows also? Yes, it is there, sir. It's there. Internally, the Windows operating system, it allocates a user ID for each and every user accounts actually. So now what happened? The user ID 0 is for root. Yes. Now when you switch to the root user here, sudo su root. Sorry, I am not a sudo user. Hence what happened? I have to exit out. So CentOS is a sudo user. So I have to log in as a root here. I switch to it. I when I exit the ID command. See, can you see the user ID for the root is always 0. So it starts with a 0. Rest all other users from 0, 1, 2 up to 999, all are system users. Above 999, like 1000, 1001, 1002, 1003, all are given for normal users actually. So root user is a super user 0 up to 999 system allocates. It doesn't provide that ID to any other normal user. From 1000 it starts actually. That's the reason you could see that when a CentOS user was created, right? The CentOS user by default it was provided 1000 ID. And next I created Rajesh. What is a Rajesh? 1001. Another more creator, Ramesh, 1002, 1003, 1004, 1005, like that it gives. It allocates a user ID. So here what happened, guys? Here in the Linux machine, in the Linux operating system, what happened, right? The authentication happen is very simple. So you will be having a login prompt actually, where you need to provide some username and the passwords. As soon as you provide a username and the passwords, what happened, right? The system does some kind of a, in the backend, it does some kind of an operation. Okay, it try to find, and how it does it actually, basically, there is a PAM models are there. Pluggable authentication models are there in Linux inside. That does the security thing, that does the checking part. PAM, pluggable authentication models, is integrated Unix login framework. PAM is used to system entry component. Whenever you want to enter inside a system, you want to log in, these PAM models are getting called. And we have something as a Kerberos. I don't know whether you have heard or not. Kerberos authentication. This is heavily used by our system admins. Okay. So now what happened that actually that, so it authenticates actually. It means that it's going to match the username and the password, and it'll allow, if the username and the passwords are getting matched, it'll try to allow you to authenticate to the system. When it allowed to the authenticate to the system, sir, you'll by default come and sit in the home directory of that user. So here what happened, if Rajesh is logging in, Rajesh will give username Rajesh, password 123, both will be matched and it will be allowed, and it knows that the home directory for Rajesh is /home/Rajesh. If a CentOS user is given, here in our case, we have a CentOS, but we don't have a password, we have a key. Oh, no problem. With the key also you can log in. So with the username CentOS, with the key, you are able to log in. Where CentOS user will come, he will come and sit under /home/CentOS. So that is a home directory for. So /home is a home directory for all the normal user accounts. You create n number of hundreds of users for thousands of users you create in a system, right? All will by default go and sit under the /home partition or /home directory. So /home is a home directory. You have to say /home is a home directory for a normal user accounts. Okay, fine. Now coming back to here, I think we went tangentially somewhere else. We were discussing about the boot directory, right? But we went somewhere actually. So here, so boot directory has these two important files, and it is also having a grub bootloader. Grub bootloader. Okay. So now, if you remember around yesterday, I was saying that, oh guys, I want to explain you about partitions, what is physical partitions, what is sectors, what is track, what is MBR. I was telling something, yesterday. MBR, master boot record, something I was saying, some big words I'm using. Have you heard of MBR, guys? Does anyone knows about what is an MBR? Master boot record. I'm not discussing anything on that. I'm just asking you. Okay, whenever you take any disk, hard disk actually, the first sector of the hard disk or the first block of hard disk is always allocated for your MBR. You Google it out. What is MBR? You'll get information. So after that, what happened, right? You will have a boot partitions, and after the boot partition, you will have many other different partitions, physical partitions you have. That is how the whole disk drive, how your hard disk, the hard disk look like actually. Always the first sector of the hard disk is MBR actually. MBR means, what is MBR means? Master boot record. Now, master boot record is information, the first sector of a hard disk or a removable device. It identifies how and where the operating system is located in order to be loaded into the computer main storage or into the RAM memory. This is what we call it as a MBR. So Rajesh, do you have to learn all these things? No, sir, not required. For you, at least it is not required. For a DevOps engineer, not really required. See, this is how the disk partition, guys. This is what the disk it looks like. And the disk always, the first partition or the first sector, this is nothing but this stripped, this is nothing but your, this is nothing one sector. The first sector of the hard disk is nothing but always your MBR. And after that, later all the disk will be under the disk partition actually. This is how it looks like actually. GDT table, ADT table, my God, CGPT table, so many are there. I learned all these things actually. GDTR table, LTDR table. There is a GDT register, LDT register, LDTR register is there in the kernel, which the kernel identifies it. There are so many things are there, sir, here actually in this. So we are not discussing all these things. So what I'm trying to tell here is that actually that so your boot directory will have this important file. So you have to say that, sir, it means that our kernel image and operating system and everything is there in the boot only. Yes, it is there in the boot only. So that's the reason you could see that if you go to the boot directory, to the / enter, you go to the boot directory, you have these two files, VM Linux image and init image. Can you see 3.10.0. something? This is the kernel version. If you execute the uname command, uname-r, yesterday I told you, this command will tell you the kernel version. Can you match this 3.10. Is it not the same thing, sir, whatever you are having here? Is it not the same thing for the init ramfs? But at the end, it is having a .img image actually. So Rajesh, can I run a file command on this? What is it? Oh, it is something, it's a regular file, no read permission. Okay, it's a normal file actually. What is the file type of this VM-? Oh, it is not, but it's a Linux x86 boot executable image, BZ image. Okay, BZ image. And it has all these permissions. Same thing, is it in a Is it also in the same in the Ubuntu also? Let's go to the flash. Let's see the boot directory. See, here you have a init rd image. See, the name is different here, but the work is same. See, VM Linux image. See, this is a microcode.cpio. Okay, this is a mother file. See, this is the file actually. So when you do, so when you you want to do a uname -r command here. What is the kernel version? Where in the Ubuntu it is there? It is 5.19 points. Are you matching the same thing, sir? It's the same thing. So am I clear on this, sir? Is it fine? I'm not explaining you. This is what I need. I don't want to explain anything. Somebody might ask, what is this configuration file? This is a configuration file for your kernel. I will tell you. Sir, what is this in configuration for the kernel? Don't worry, sir. You need not to understand all those things. This is a configuration for the kernel, or this is a configuration for all your drivers, whatever there in the kernel, all the configuration file, your kernel, it is there in this config file. So come over here in the CentOS. See, you have something as a config file. This is the configuration for your kernel. Sir, can I open? Yeah, you can open that file. No doubt. No problem. You can open the file. See, this is the whole configuration file for your kernel. You see at the top, x86 kernel configuration file. Guys, when I was in HP, I was playing with this file actually. I was creating this config file, everything, and I was playing this file, and I was doing a kernel recompilation. Kernel compiling, I was doing everything with the help of this config file. So this configuration file, this boot image, and everything is there in the boot directory. Okay. That's what I'm saying, that if you are a DevOps engineer, if you're working in a company like Intel, okay, where you're working along with the system level system level, you're working as a DevOps engineer. If you are in your NetApp company, if you are in your EMC company, whichever company who are working on mostly on the like chip level, hardware level, and who are working like company like a TVO. There's a company by name TVO. I think have you heard of it or not? It's a very big company, sir. TVO company, TIVO. This is very good companies are actually. They're into all the streaming products, multimedia products and everything. Here also, you will find the DevOps engineer who are working here under TVO. One of my friend is working under the TVO company. He's getting paid a 78 lakhs package, sir, actually. And this fellow is completely working on the system level. His task is to compile the kernel. His task is to create an image. His task is to create a init RAMFS. His task is to build the models and everything. Many things he does, but he's a DevOps engineer. So you might ask, Rajesh, their Jenkins is used. Yes, they are using Jenkins, sir, because they're calling it. They're calling a set of commands to do all the things. They are calling a Jenkins. They're calling a Jenkins. They're using a Jenkins tool. They will use some tools and all like that. They might not use a Docker or Kubernetes and all because orchestration or Dockerization and all is not required for them. But some of the tools they are using. But yes, they are using the build tool, like make build tool, some other Yacto build tool. They're using all those build tool to build the application. They're doing that and build the firmware. So there also you'll find the DevOps who are working, and they're highly paid, sir. They're highly paid actually. But they have a lot of responsibility work. They have to learn the system in a very deep level, and then they can they can work very comfortably. Right? So company, if you go to the companies, the Acme company, you'll find a lot of DevOps engineers who are working on the networking level. They are doing so many configurations of a lot of devices and everything. Yes, you will get an opportunity in that level also, where you can play if you go to the Acme and you go to the Juniper Networks company, there also you'll find DevOps engineers who are playing a very active role, sir. Many things they are doing it, but they're doing everything under the system level they are doing. So it is very complex to understand, but yeah, pay is very high, sir. Highly paid they all are. Okay. Sorry. Okay. Now coming back to here. So now home is the home. We discussed that it's the ultimate home directory for all the user accounts. Lib directories are very important, sir. All your system libraries are there under the lib directory. Like for example, all your libraries. Broadly, we categorize a lot of libraries into three parts, sir. Static library, Shared library, you might have heard about the shared library and dynamic library. Some of the DevOps engineers are involved in building the libraries also. You might have seen.
No voice, sir.
Sir, now? Hello?
Yes, you are
You
audible.
are able to hear.
Sir, voice is not there.
We are not able to hear.
Guys, can you hear me now?
Yeah, now it's
Yes, sir. Now it's fine.
Oh God, there is some problem, sir, in my mic set. I will fix this issue. Okay, thank you, sir. So under the lib, sir, can you see under the lib? These are all the libraries, sir. Libraries which are there. But I would say that one of the very important libraries which is there under is a module actually. You see, and I am under lib. Okay. If I go to the modules directory, enter and say ls, and if I go to the kernel directory like 3.1 point something, 45 or whatever, 45, enter and say ls, and if you go to the kernel directory again, pwd, I'm under this path. /lib modules, some version name, and under that there's a kernel. And if you do an ls, these are all the kernel modules. So this path is for the kernel modules. All kernel drivers, all kind of a drivers modules are there here. If you go to the cd to the driver, enter and say ls, can you see Bluetooth driver, block driver, I2C driver, all these are GPIO driver. Suppose if I go to the Bluetooth driver, to the Bluetooth, you see there's a file known as .xms. These are all the drivers, sir. Oh, beautiful. Oh, these are all drivers. Yes, sir. Okay, Rajesh, come out from here. Rajesh, there is something known as a FS was there. Is it a file system? Yes, sir, it's a file system. FS. Enter. See, these are all the file system which is supported by a Linux. Can you see there is something known as a ext4 file system? Yes. Go to the cd ext4 file system. Enter and say ls ext4.co.xz. This is your ext4 file system driver. FAT file system driver, it is there. So do you find anywhere NTFS driver? No, it is not there. NTFS is not supported as of now in this kernel. They have removed it, but you can install it. You can even install the driver. It will work actually. Okay. So now why I'm telling you all these things, this is not really required, but I'm just telling you for the knowledge actually. So what happened in the kernel level, whenever you want any model to be loaded, actually, whenever any model to be loaded, that models will be loaded always under this path only, /lib modules version, kernel version. Under that, you have the specific folder. From there, it will try to load that model actually. So now there's a command by name lsmod command. This command will tell you what are all the models or what are the drivers which are running in your kernel space or in your kernel. These are all the models which are running in your kernel space. See, these are the models. See, model it says. Can you see there is something like the ext4? Anywhere ext4 is there? IP tables, ext3, blah, 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 blah. Anywhere, sir? Or some other base driver might be there. That's what ext4 might not be there. Right? So ext4 might be there. No, it's not there. So Rajesh, can I load the ext4? Yeah, just see mod prop ext4. Your operation is not permitted because you have to switch to the root user. Yeah, the model is loaded now. Now if I do an ls mod, can you see here somewhere ext4? Yes, this model is loaded. Yes, exactly. Yes, exactly. So mod prop, this command, ls mod command, mode proper command or insmod command. These are all the commands which you can play with the kernel models. You can load the model, you can unload the model, you can remove the model or mod command by using this, but this is all not required for us. I'm just telling you. So under the lib directory, if you come over here in the diagram, under the lib directory, you will find all the system libraries. And also I showed you that even there are kernel modules are there under the same lib directory. So from there, the kernel modules are getting loaded. Okay. Good, sir, but enough is enough. I don't want to learn more. Fine, that's fine. USR, user reserve directory, user system reservoir. We say USR, user system reservoir. This is very important directory, sir. This directory, if you are installing any softwares in your Linux that is on Ubuntu or CentOS, all the softwares are getting installed here under the USR. Similarly, in your Windows, whenever you're installing any kind of a software or any kind of a software installing, where it will go? It will go, sir, it will go to the C drive. Under C drive, sir, there are program files, sir. There's a folder by the program file. Under that, everything will get installed, sir. You will say like that, actually. Correct? So this is the path where all the softwares are getting installed whenever you're installing Windows. Similarly, in Linux, everything is installed under USR directory. If you go here, cd / enter and say ls, can you see there's a USR is there? All your softwares or whatever the yum packages or RPMs or whatever the Debian package you install, in case of Ubuntu, everything will get installed under this path only. It cannot get installed into any other path. Whenever you're installing a software, whenever you're using a yum command, yum install space HTTPD, you're installing a HTTPD package, so it will get installed actually. It'll go install in a USR directory. Like for example, if you say yum install HTTPD, okay, you need to go root perform. You have to do a sudo command, sudo yum install HTTPD. See, you are installing HTTPD package now. Okay, sir, we have not yet come to the package manager. We have a separate topic for that. Okay, I can install it. Yes, we can install. See, HTTP package is getting installed. See, HTTP package has got installed. So where it is getting installed, sir, you have to say always under the slash. There is a USR is that there it will go and it will install it. This is the path or this is the directory where it will go and install it. Oh, it means that all it will go and install it. Now, I have a very, very, very basic question for you guys. Very simple question. I want to know from you guys, what is a package? Suppose you are installing any software. What that software contains? Can anyone tell me? You can unmute and tell me. Whenever I'm installing any package here in Linux, actually, like HTTP package, I use a yum install command, yum space install space is the package name. That package got installed, but that is fine. That is software. But what is that package is all about? What it contains?
Application code and its dependencies.
Application code and dependencies. Okay, good. But do you think that
It's
the
a
code
file
will also
of
be there,
exe file.
exe file. Sir, whether that my question is that, sir, whether the code will also be there, what are you saying? In that package? No, code will never be there, sir. Binary compiled code will be there in that actually.
Yes.
Compiled code will be there. You have to tell like that. So the package, what are the content cards? Sir, it contains the binaries. It contains some standard libraries. What are the libraries required? It has a binary compiled code, and also it has some kind of a scripts also, so that the scripts will get executed. Now, when I'm running yum install, when I'm running n install HTTP, sir, who is displaying like this? Transaction summary equals blah 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 like this. Install one package like this. How this is all happening? Because, sir, this package, intern, HTTP package, intern has a script. That script is actually displaying this way. You could see that, it is installing, Who is doing everything? And inside this HTTP package, sir, there is a script which is written. That script, when it is getting executed, it is showing you all these things. So whatever the user is seeing here, it is very installing, verifying. These all are coming through that script itself. These strings are not displayed by your kernel. No, kernel is not displaying these things, sir. Here, what happened in the HTTP package, those scripts are there, those are getting called. Now your question comes, Rajesh, can I extract it? If I download this HTTP source code package, and if I extract, can I see that scripts and all? Can I view it? Yeah, you can see it, sir. Is the same thing happen in Windows? Can I download any package and I can extract? I can say you cannot do that. It is not possible because they will give completely as an exe file to you. Exe, you cannot extract and see what inside it has actually. Whereas in Linux, like the RPMs, right? Basically the RPMs, right? You can actually extract it and you can do it actually. You can extract and you can view the content, what is there in that RPM or in the packages actually. That is possible in Linux because it is an open source, right? When they're building it, yes. When you're building it, you can even view what and all you're doing actually. So what they do, how they do it, build means they use some concept known as a spec file. They use a concept of a spec file. With help of a spec file, only they try to build a package in Linux or in Linux, either in CentOS or either in RHL or either in Ubuntu, any flavor of Linux you see, how they build the package. There are developers or there people are there, DevOps engineers are there who build this package. How they build this package, how they create this package with the help of something with a spec file. They call it an RPM spec file. If you go to the Google and you just say RPM spec file, see, you will get it. RPM packaging guide. See how to build a package. You have a way. This is a spec file actually. You need to use this way. Sir, I don't know to learn all this thing. Yes, we need not to learn all this thing. This is how the spec file, by using a spec file only, you do it. Yeah, this is what it is actually. This is what even I was involved in. Oh, yeah, prep is there. See, install is there, how to do it, see how to create a directory, go to this user directory, go and install this. See, beautiful, man. This is what it is. So this is a spec file, you have to write it actually, and you have to run a RPM build command to build that spec file. Then you will create an RPM, or then you will create an RPM. That RPM you can install using yum command. Yum install and specify that RPM, it will go and install it actually. Is it same thing in the DPKG or in your Ubuntu? Yes, it's the same thing, sir. You have to write a spec file. So this is also one of the very interesting area. A lot of people are working. You know, in many of the organization company, right, they will build a package actually. So you need to learn about the spec files. Some of you are DevOps engineer. You would say, sir, for Java building and all, you have something as a tool known as a Maven tool. Yes, Maven tool is there. Correct. Maven tool is going to build your Java application, right? Maven is known, but how it works and all, because that Maven in turn works with the help of a pom.xml file. You need a pom.xml file. Pom.xml file is a build. It's like a XML file. It is something like a build file actually. So that pom.xml file will have information about what type of file you need. Either I need a jar file or a var file or a ER file. That information. What are the dependencies are there? Where I can fetch the dependencies. All those information is there in the pom.xml file. Whenever you're doing a Maven, when you're calling a Maven command, mbn space package, it's going to always look for that pom.xml file. Through the pom.xml file, it gets all the information, it gets the dependencies, it downloads all the dependencies, compile the code, make it package, and it will give a package to you. Similarly, here in case of Linux, either in Ubuntu or anything, you are building an RPM itself. There you have to use a spec file. Clear, sir?
Yes, sir.
Yes, correct, sir. RPM-AVH, RPM, good. MVN, NS build, and very good, sir. All these are all these are build tools actually. Yes. Clear, guys? So something
Yes.
you're new learning?
Definitely, sir.
Okay. Now, so thank you, Ram. Okay, so now you understand that whenever any package is getting installed, where it has to go and sit, it has to go and sit under the USR directory. Similarly, there's a var directory. All your system log files and everything, your system log files, right? Your kernel files, everything, all the log files, important log files will be there under the var directory. Var directory will have a logs. All the logs are placed under the var directory or under the /var directory. Very important. Now, somebody might say that, sir, I want to display all the kernel messages or the system messages. How to display, sir? Please go to the system and run a command known as a dmessage command. See, this will show you all the system information, all your kernel information. You want to see all the information, what kernel is doing, you have to always run the dmessage command. The same command, even it is there in Ubuntu also. Dmessage. Okay. Sudo dmsc. See, this will give you the system information. Whatever the kernel is doing, right? You can Sorry, you can display through the dmessage. This is also very important command, dmessage, because many times what happened, right? Your system kernel might be doing some operation. You might be running an application, but that application might be slow or it might not process properly. There you want to see, you will run a dmessage and see, is there any log I can find where operating system is facing some issue or it is throwing some error or exception. You will see these messages. You will try to grab that string and see it as what it is doing. Like that, you will do some kind of a troubleshooting you will do when you're working on a system. Okay, fine. So now what happened, right? Whenever you are running a dmessage command, when I'm running a dmessage command, actually dmessage command is actually displaying all the content from the /var log messages. This is the file from which it is taking and it is displaying it actually. So if you go here in the system and if you do a cd to the /var log, cd to the /var, cd to the log, and can you see messages? See, this is the file. To do a cat of messages, permission denied, do a sudo cat messages. See, the same information, whatever you executed dmessage, right? So dmessage is basically looking into this file only. It is always looking into this /var log. It is displaying the content of this file only. So guys, so we'll have a separate session, as I said earlier, like we'll have a separate session on how you can monitor the logs in Linux. Very important, because you will be playing many times with this log messages and everything, right? Like for example, you're installing the Apache server. You need to monitor Apache logs. Apache logs, everything go and sits under the /var itself, /var directory itself. Right? Similarly, you have installed the WebLogic server. You have installed the Tomcat server. You have installed the DNS server. You have installed the DHCP server. You need to monitor the logs of the DHCP server. You have to go to the log directory only. So there are some system level logs are there. There are some other some user defined logs are there. You need to monitor everything. There are some application logs are there which might sit in the var, which might not sit. But even you have to monitor those things also. But whereas for the systems, always what happened at /var is the ultimate directory where the system logs are placed actually. For an application log, it might be under var log, /var log, it might be in some other location. It depends upon the application developer. He might not want to put every message as what are the application throws the message, right? That he don't want to put on the var. He will create a separate directory. Under that directory, logs will be getting generated. Right? So in every industry, what happened, right? Whenever the logs are getting generated, you see that in every company, they will write one script, a log rotation scripts they write actually. They'll write a log rotation script where it will redirect the log into some particular path. So always a user is being told that, always a DevOps engineer will be told that, hey, whenever you want a log, man, go to that path and see it, man, we'll say. Developer will say to developer, hey, you want to see the log, go to that path and see. Why? Because they have written a log rotation scripts they have written through which they will reroute the log from some location to a predefined location where they can monitor it actually. Clear, guys?
Yes, sir.
So did you know all these things? Log rotation scripts and all?
No, I don't have idea.
No, Rajesh.
No, when you go to the industry as a DevOps engineer, you have never been told many things because the developers will know everything, sir. Developer is a guy who knows everything, whatever he's doing. He'll only tell you, hey, don't ask me any question. Go to that path and see the log. He will say like that. We being a dumb people, we'll only follow him what he's saying. We'll go to that log. Okay, sir, I got the log, sir. Fine. Be happy. But why I have all those things? Okay, there is something behind that actually. Right? So that's the reason that whenever in the industry, when people are working, whenever any person, he starts his career as a developer, right? He's a guy, he's a person, guys, who's going to learn many things actually. It's not the DevOps engineer who will learn many things. It is not a cloud engineer who will learn many things. In the software world or in the software industry, a developer is the only person who learns many things actually. That's what I always appreciate developer, because a developer is a never ending. He will always be learning his whole lifetime. And he's the highest paid guy in the industry. DevOps engineer, like we all are support engineers. we will be having a very limited knowledge. We will not be going out of boundary and understanding it. Developers knows many things actually, and they are the hearts. They manage the application. They know how to play with that application. They know what are the things to be made that application to work. They know many things. So that's what they know, everything, internal, external, everything they know actually. So that's the reason when you go in the industry as a DevOps engineer, please make a very good relation with the developer, because you can learn many things from the developer. So that's the reason what happened. DevOps engineers are very soft engineers. You should be always be soft. You have to learn many things from the developer, right? So your work, right? It depends upon his inputs also. Correct? Do you agree with this? Do you agree with this statement?
Yes, sir. 100% agree with you.
Okay. So that's what, sir. Now what to do? Our age is gone now. We can't become a developer now. But developer is the one, sir. Actually, you have to. Why people are dying to become a developer, or we have to, because we have to. We'll be learning many things, sir. 100%. All what we are playing is a very creamy layer we are playing. That's all. We might not know many things. We might do up to one level. We can do a troubleshoot, sir. Beyond that, we cannot do it because we don't have knowledge. Then we have to catch on the developer and see, oh, developer will do something in the backend. He will do, and you will see that he'll fix the issue also. And then you start jumping around. Oh, you ask, oh, how you develop, how you fix it, man. Hey, he'll say, don't worry, man. You need not to know. No, please tell me, man, how do you fix it? Then he will try to tell how we fix it. Oh, then you'll understand. That's the reason, guys, what happened. A person who's staying for industry in one company for longer duration, right? And is very enthusiastic, right? He will learn many things actually, because that he has built a relation with a lot of teams. He has built a relation with the developers and the tester. They give a lot of inputs to the DevOps engineer. He will closely work with the developers, right? It is like a close friend. It's like a pet friend, right? DevOps will be like a pet friend. We will learn from them. If a person is staying for a very long duration of time, right, he will maintain a very good rapport with many team, with many developers. And you could see that some of the developers are also dependent upon the DevOps engineer also. Like in my previous organization, Lumen Technologies, right? A lot of developers were dependent upon me only. They will wait when Rajesh comes. No, we will work with him actually, because that I understand the system very well. I understand the whole the whole architecture. I understand. So whenever we closely work, right, I will give a lot of inputs to him. He will give some inputs to me. So we will always be in a SWAT call and we'll fix that issue actually. That's how it is. That's how it works. So I had maintained a lot of developers. I mean, I had a very good rapport with a lot of developers, sir. And some of the developers, they call me now also, because I left the Lumen organization 3 months back actually. They call, hey, Rajesh, why you left the company, man? You should have been there. Like that, they said, because I had maintained a very, very good rapport with them. And I closely worked with them, sir. I was going to the desk and trying to understand how this works, and they were very open to share all the details with me. And because that, see, if you have an approach now, sir, if you approach me, suppose that if you approach me, sir, if you put 2 steps in front of me, no, I will put a 10 front in step of you, in front of you, because I will understand that, oh, you are interested, so I will also show the interest actually. What the same way, when the DevOps engineer shows an interest, he approaches the developers will understand, okay, this fellow has an interest to understand. He has interested, he has come with a problem statement. So let me solve his problem. If you never go and ask him, or if your approach is not good, no, he will not show any interest on you. So the biggest thing in the industry is that actually you have to build a rapport with all kind of your external stakeholders, like developers, testers, and everyone. You have to maintain a very good relation with them. Then only you will become success. They'll become success. You'll also become success. Okay. Now, I think we took a lot of time. Okay, log and a proc file system. Basically, this file system, it is a special file system. We say proc file system. This special file systems, proc file system, you might have seen today. I was saying something about this file system. This has the information about the kernel, about the system. About the system itself. Sorry. Yeah, the sys file system, as well as the sys file system, as well as the proc file system, both of these has a information about the system. They maintain information about the system itself, about system, or we call it as a kernel or kernel. empty directory, opt directory, these are external folders which are basically used for mount point. If you are having any device, you want to mount to a system, you will mount either through opt directory to empty directory. These are something like directories. These are empty directories actually. Any external device, you can mount into your system to the opt directory. Okay. Any external file system can be mounted on opt directory. etc directory, very important directory. etc directory will contain all your system configuration files. All your system configuration files are there under the etc directory. System configuration files. Some of them were saying, sir, etc password. Someone were saying, what is it? We'll see. Now, most of this file will end with a .conf as an extension. If you go to the etc directory here, cd slash, and I could see that there's an etc directory is there. etc is there. See, can you see? Most of the files ends with a .conf directory. .conf, 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 .conf. This is the configuration file. This is all the configuration file. Now, two of the important configuration files are password file, and there is something known as a shadow file. Can you search anywhere shadow? SHADOW. Can you see shadow file? Password file, that is etc password file, it holds the information about all the users. If I do a cat of /etc/passwd file, see, it has
second last column. There is
yes,
from bottom fifth.
1, 2, 3, 4, 5. What is it?
Second last column, shadow file is there.
Yeah, correct. We saw it. Yeah, right. What is it? Right here, shadow file. Yeah. Yes. So now you have a password file is there. So I was saying no PAM plug PAM model, PMD, PAM model C, PAMD is there. Your linking loader library, ld.so.conf is there. This is called the linking loading library. Your grub configuration file .cfg, it is there here. Grub.configuration file. Your shadow file is there. All your cron tabs configuration files are here actually. Your DHCP server configuration files are there. Your HTTP configuration files are there. So you will say MOTD, message of the day. This configuration file is there.
Services are there.
Yes, all services, configuration files, system services, server application services. For example, you install DNS server, you install DHCP server, you install NFS server, you install NIS server, Squid server, Mail server, Samba server. Any server you install, guys, you will get all the configuration file for all those servers under the etc directory only. Correct? And you could see that there is one more important file as a dir_colors. Oh, what is this, sir? dir_colors. See, guys, when I told you that, when you do an ls and enter, you could see Pratap is a directory which is in a blue color. Vaibhav is a directory is a blue color. How we are getting this coloring effect? Because of this configuration file known as a dir_colors. Oh, can you check it, Rajesh? What is it? Cat dir_colors. Sorry, cat dir cat space /etc dir_colors. Yes. See, can you see it? If you go up here, can you see whenever you are creating a directory, dir, where is the directory, sir? Whenever you are creating a directory, whenever creating a dir having a 34 number. And if you go up, what is the 34 number? 34 number stands for blue color actually. Somewhere it is, see, 34 blue color. Whenever you are creating a socket file, a socket file is 35. 35 is the magnetic color. Whenever you are having a character device file, CR, 33 number. 33 is a yellow color. See? Now can we correlate everything? Something? So Rajesh, whenever I'm executing ls command, you are getting a color. But how this files with the color is getting? So when whenever I'm creating mkdir, Amar, I'm creating a directory. At that time itself, it understand, okay, what coloring should be given for this directory, because it will refer to the under etc dir colors. It refers that, okay, this is a directory type. Amar is a directory because he's using mkdir. Let us give the blue color for that. It will give the blue color. Means it will display with the blue color. That's what. Not like it will give the blue color. It will display with the blue color. Based on the file type, it understands. Because Amar is a directory. If you say a file command and Amar, it's a directory, you know. So how it gives it, it's a coloring. When you do an ls, it always gives the coloring actually. Clear, sir? If you don't want to do anything coloring, you can say slash and say ls. See, it will not display any with the coloring effect. Clear? Now, coming back here. So, under the etc directory, you have all the configuration files, sir. Very important configuration files are, one of the important configuration are almost all the important configuration file only, sir. No doubt about that. You have a password file and you have a shadow file. If you open a password file, can you see here, root user, he's a user. He's having a user ID 0. He's having a group ID 0. And where he logs in, whenever a root user logs in, by default, the root user logs in under /root. And what is the shell he'll get? He'll get a bash shell. Apart from 0, the user ID 1, 2, 3, 4, 5, up to how much? 9,999 users are for system users. So Rajesh, whether the LP, sync, shutdown, mail, operator, game, FTP, nobody, all these are system users. Yes, these are all are system users. See, these all are system users only. So root user is 0. Apart from that, all these are system user. Apart from this 999, see, immediately 1000 will be given. Who is that? CentOS user. Super. Rajesh 101 is given. Just now I installed Apache. Apache is also a system user. It is not, but it is given a user ID 48. But if you see it for a normal user like Rajesh, CentOS, or even with a root, you will get by default when you log in with the system, you will get a bash shell. See, CentOS, you will get a bash shell. For the Rajesh, you will get a bash shell. But for other non, you don't need a shell. So slash has been no login. It means that you will not get any shell at all. For this user, system users, there is nothing like a concept of a shell. Why it needs a shell? It doesn't need a shell. It will be working with the system itself. It will be working with the kernel itself. Kernel doesn't need any shell. Whenever any external user who is logging into the user space, for him, he needs a shell. So that's the reason at the end you will see you will get a bash shell. Suppose you say that, Rajesh, whenever I log in, I don't want to get a shell, man. You will say etc password, go here. So he will say, Rajesh, means you shouldn't touch this file. Oh, whenever Rajesh is logging it, he shouldn't get any shell, man. He should never log into the system at all. No problem. So I think I normally opened, I have to use sudo vi etc password. So come over here. Sorry, I think. Open this file. I mean, I'm just telling you. Okay. So you can change this line. Slash has been no login. Say this file. So CentOS is there. So now what happened? Switch to Rajesh. The account is currently not available. You will not able to log in at all. So switch to the root user. Okay. Whether the root user from root user, can you switch it? Because you are not getting a shell itself. How you can log into with the user, with that user? Because in the etc password file, then I change it to from /bin/base2, I change it to /bin/no login. It means that you will not get any shell at all. Right? That's how. So etc password file. Open it, change it to /bin. Okay, fine. Some people might ask, sir, by default, /bin bash is given, any other shell is given. No, by /bin bash itself is given. If you want to change to any other shell, you can change it to any other shell. That is with the chsh command, you can change it actually. Later I will tell you about that. So now you can switch to Rajesh. Yeah, now you can switch to the Rajesh. because you have given the shell action. Right? Now, the thing is that now this etc directory, etc directory, it's a very important directory, guys, because it holds the system configuration files. All your system configuration files, everything will be there under your etc directory. And the etc directory contains all the configuration files. For example, you have passability file, you have a shadow file. Now, this passability file, as we showed here, this has the information about the users, and also it has information username, and also it has information about the password. But where the password is saved, because while creating a Rajesh user account, I gave the password as 123. Now the password is saved under this X actually. But you might ask, Rajesh, what is this X? This X is a pointer to the etc shadow file. Okay. So now I'll do a cd sudo to the cat of shadow. See, Rajesh is there. The password 123, it is there, no? That 123 password is in an encrypted format. See, for the root user, there is no password. That's why it's showing double bang, 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 no password. It is a passwordless. Suppose you say that, Rajesh, I want to set the root password. I'll just say sudo tswd root. You are setting a root password now. What's the password I'll give? I'll give the password as something like Red Hat, REDHAT, enter. REDHAT, enter. Root password. You have set the root password now. Now can I do a sudo of cat of etc shadow file? Yes. Now is it the password? See, can you see now the password is there? Yes, the password is there now. Earlier it was doing double bang. Bang means no password. Double exclamatory, like this, exclamatory. But now, see, for all the other users, it's all double exclamatory, because there is it is all system users, guys. No, sir, it is not possible, sir. You cannot decrypt the password, sir. Because, okay, so now whenever you are, the password is encrypted, right? You cannot decrypt it. There is nothing like a decrypting software where you can decrypt and you can reverse engineering to, get back the password. It's not possible. Okay. So there are a lot of encryption algorithms are there which are running in a system. When you're creating a user account and when you're setting a password, that encryption algorithm will encrypt the password, and that encrypted password, it will going to store into the etc shadow file. Now, whenever you log into the system, right, what happened that whenever you give the username as a Rajesh and the password is 123, it'll try to check whether the username Rajesh is there in the etc password file. Yes, it is there. So when you're doing under etc password, whenever you log in the system, whether Rajesh is there, Rajesh is there, fine. Okay, he's giving a password, something 123 password. So that when you're giving 123, how the system will do is it'll convert that 123 what you're giving into the encrypted form. It'll convert it, and then it will match this file. Matching with this file, with this etc shadow file. It matches. Okay, whatever the Rajesh 123 is giving, it will match with this. Yes. Now the password is getting matched. Now it will allow you to log into the system. If you're giving some wrong password, it said that incorrect password. Like it will throw error, right? Incorrect password, like that, right? How it does, because it will try to check it actually. It'll try to check it. Yeah, delete password. Yeah, del password, sir. No. We can we delete the password? Yeah, you can delete the password, sir. What is that? We can delete the password. We can unset the password. That is there. That we have a command also. Del password is also there. Yes. Or password password -d command, -d option is there. Using that, you can delete the password also.
It is specify the username. Delete password -root. Likewise, specify.
Correct. Or else password -d root. It will delete the password. -d option, delete. Okay. Now, so now you understand that this is one of the important configuration files, and we as a DevOps engineer, many times we'll be playing with this folder also. If we have an access to this folder, or else we want to do some operation onto the folder also, right? If we have an access, right, we will definitely, try to, play even with this, some of the configuration files under the etc also. Like, for example, whenever as a DevOps engineer, what you do, you're trying to install an Apache server. You want to do a lot of configuration. What you will do here, I have already installed Apache server. What you will do, you'll go to the etc, Okay, HTTPD, see, HTTP.conf file. Under that, you have HTTP.conf file. See, you will play with this file, sir. This is a configuration file for Apache, So you need to have a permission to do everything. You, as a DevOps engineer, with your account, they will give the permission because you have installed it, right? You will have a permission to play around with this file. So this is a configuration file for your Apache server. Similarly, if you go here into the Ubuntu, this is your Ubuntu server, right? You have to say sudo apt update. First, I will do sudo apt update to update the package repositories or to update the repositories. And after that, what I will do, I will try to install the Apache package. How to install it? Sudo apt install Apache 2-y. Enter. See, you are installing an Apache server. When you're installing an Apache server in Ubuntu, right, where is the configuration file will be there, sir? It will be under etc to etc Apache 2. See, installed it. Now etc under you have something as Apache 2. See, this is a configuration file. Here you have apache2.conf is there. Yes. You don't have SSL, you have to install SSL also. You'll get SSL.conf. Here we don't have SSL. You have to install it. Right? So, I mean, you have to play around with some configuration file, and all those configuration files are there under the etc directory only. Is it clear, guys? Still here. So these are very important things which we cover today because I know that this was supposed to take longer time, but anyhow, we have understood, okay, we have understood that how the file system look like. This is our entire file system. This is how it looks like. It starts with a slash and it has all those subdirectories. Clear?
Yes, sir.
Okay, guys, fine. Shall we continue for some more time or we'll stop it? We'll stop it?
Sir, we'll stop for today.
Okay, sir, it's fine. See, already 7-8 people logged out, sir, because when people joined, right, they were around 20-26 people were there. Now it is 17. Fine, that's fine. So what is the types of shells and all, like we will discuss in a, maybe I will call you, all of you, on maybe on Tuesday morning, 8 o'clock, I will call you. Okay, so I will see if all the people, most of the people are joining on morning 8. So what we will do by this next week, right? We will try to conduct on Tuesday. We will try to conduct on Thursday. And again, we'll try to connect on the Saturday. Like that, on 2 sessions I will take next weekend, so that at least we will cover some commands, and also that by next week, we are free off with the commands. We know everyone knows all the commands. So we need not to worry about the commands and all. Then we can concentrate more on the other aspect of the things like your the scripting part, actually, so that will be we can concentrate more on that. That's what I was thinking. So this week we'll try to cover 1 or 2 or 3 sessions we will take, and then like we will cover up most of these things, whatever we have, right? These things we can cover up. Clear? And when we start from the next Saturday, right, we will start from our regular scripting. Yes, sir, we'll stop for today. Sir, yes, 8 a.m. Giri sir, on Tuesday, we will plan to take another morning, 8, 10 or 8 o'clock, or I might be something 5-10 minutes, little bit delay, but that's fine. 8 o'clock I will take, yeah. So guys, 8 o'clock is suitable for you all?
Yes.
Yeah, okay. Thank you. So let me stop the recording.